here we go. So the parent function was 2 to the power of x. Do you recall that?
Yeah. I already got that.
And then the transformation is 1 unit to the left. So we're going to start by graphing the parent function, but we're going to make a table to do that. Here's x, here's 2 to the x. All right, so 2 to the power of 0, anything to the 0 power is 1. Okay, so 2 to the 0, you're putting 0 in for x. We're going to start here at 0, not at the negative 2s. That's just 1. 2 to the power of 1, well, anything to the power of 1 is itself. So these things I'm boxing in, these are generally good things to like remember or to have, you know, there with you. So 2 to the 1 is 2. 2 squared is 4.
Yeah, I already got that.
Okay, so we made a table of this already, is what you're saying. Okay, so I thought we were done with this problem. Did you not get the first transformation or not?
I already got the first one, which is 11. I got the
it.
parent graph and the first transformation. So now we need to do the next transformations.
There's only one transformation though.
Then what's the vertex?
So this one does not have a vertex.
Domain and range?
We can talk about domain and range. So let me snip that part in. Let me grab that here. Okay, so the vertex, you can say like not applicable to this problem. The domain is all real numbers. You have yet to see a function that has a domain that isn't all real numbers. So all the domains that you know about are all real numbers.
Yeah.
So let me snip in that graph that we found, that we made for last time, and then we'll talk about the range, but we got to look at the graph to do it. So I'm going to grab that. Okay, so here's the graph from last time. Do you see, let me zoom in here a little bit. Do you see how it kind of like it approaches 0 it approaches the x-axis, but it never goes across the x-axis? See how it's kind of approaching it? I don't know how easy that is to see on your side. And then it goes up forever. So the range here is y greater than 0. Y greater than 0.
Y greater than 0. There's no vertex.
There is no vertex. This one you can say not applicable or doesn't have one. Whatever you say here will be fine. Your instructor knows that they just copied and pasted, and this one doesn't have one.
Okay. Okay, I got it. I got that down.
Great. Now we're gonna get all these done today, but did we do 13 yet?
No, we didn't do 13.
Okay, so 13's next, and this will go fairly quickly because we've already done a bunch of quadratics. All right, so with number 13, it says name and write the equation of the parent function. Do you see that there's an x squared here?
Yeah.
So what is the parent function?
The parent function is 5.
X squared.
X2, yeah, x equals 2.
X squared, yep. All right, now this one has two transformations. Okay, the first one is from the 1/2 and the second one is from the -5. Do you remember from last time or from school, what does a number out in front do? This 1/2, do you remember what that does?
I need to write this down.
Okay.
Okay, so
I'm asking you, like, do you remember what the number out in front does? Okay, so what it does is it's a vertical and it's a shrink.
Mm-hmm.
by 1/2.
1/2. Okay. Vertical shrink by 1/2.
Yep. And then this -5 is down 5 units. So there's only 2 transformations.
I know. Okay. All right. Got it.
All right, so the parent graph is y equals x squared. Okay, so that's 0, 0, 1, 1, 2, 4. We've done this a bunch of times. It's always the same 5 points for the parent function. And I'll show them over here to the right, but we've done so many of these, like I talked about, you got to like roll out of bed and you got to know that these are the points on the parent graph. Okay, so let me know when you get this graph down, please.
Yeah. Yeah. I'm writing that down.
Great.
Yeah, just okay. Got that down. I'll just write
Excellent.
down my. I'll
Excellent.
write down my. I'll just write down my transformation, my line of it.
Yeah, so we're going to first do a vertical shrink by 1/2. So what I'm going to do here is show you that transformation. Actually, I'm going to go, no, we can do it here. Sorry. So that affects the y value. This vertical shrink by 1/2, it means take the y value and you multiply by 1/2. So each of these y values, we're going to multiply by 1/2. X is going to stay the same. Okay. So you got 1/2 of 4. You got to take half of 4. That's 2. Half of 1 is 1/2. 1/2 of 0 is 0. 1/2 of 1 is 1/2, and half of 4 is 2. And then we're going to graph that transformation. So let me snip in the transformed transformation. Okay, so we're going to graph these points. -2, 2, -1, 1/2, 0, 0, 1, 1/2, 2, 2. Graph these points here. So this is the transformation vertical shrink by 1/2. Okay, so I would get down this table on the right and then this new graph, and then we got to do one more transformation.
Yeah. Got it down.
Excellent. Okay, so our next transformation, what's the second transformation in this
The
problem?
second transformation.
Yep.
Okay.
What
Down
is it?
5 units.
Down 5 units. So what that does is it affects the y value again. So we're going to go down 5 units. So that means each of these y values are subtracted by 5. So you subtract by 5. So it's 1/2 x squared minus 5. So the x values stay the same, but you subtract 5 from each of the x values. So minus 3, minus 4.5, minus 5, minus 4.5, and minus 3. And then we graph those. We're going to graph this. This is our last transformation for this particular problem. So we're going to put those on another graph and see
Okay.
see what we can come up with here. So you're going to see it's going to be the same graph as the previous problem, but just shifted down 5 units. So it'll look pretty similar to what you just did. So that -1, -4.5, 0 minus 5. So again, just kind of looks like this here. This is down 5 units.
All right.
All right, so you got that down?
Yep.
All right, so the last thing on this problem is to find the vertex. And the vertex is that point it's either at the bottom or at the top, depending on whether it opens up or down. So in our case, it's this middle point here. So it's 0, -5. What is the domain? What is the domain for all of these functions?
Okay. So the domain is all real numbers.
All real numbers.
Why?
Yeah, the range is y, and because it opens up, it's greater than or equal to, and it's whatever the y value is of the vertex. So in this case, it's y greater than or equal to -5.
Okay. Okay.
All right, so we're going to move to question 10, yeah, 10, and then we'll finish off with question 14. So these are going to be a little bit different than what we've been working on, but you can definitely do them. All right, so question 10, let me know when you get there.
Okay, so we're in number 10.
Number 10, yep.
All right, I'm here.
Okay, so
Y equals so it's y equals x2.
That's right, it's x squared. Perfect.
And so yeah, and the transformations presents.
So actually 3 this time. And the first transformation is this +3. Do you
Wait,
remember? Go ahead.
+3?
Yeah, see that +3 there?
Yeah.
Does that move it left or right? Do you remember from class?
3, it goes at the right.
Actually goes left 3.
Left 3.
Left 3 units.
Left 3 units. Okay.
Yep.
All right.
This 2 out in front is the next transformation. It's a vertical stretch by 2.
Vertical stretch by 2.
Right, and then the -4 is the last one. That's down 4 units.
Okay, I got that down.
All right, so the first graph we're going to make is the same one we always make. It's the parent graph. It's the graph y equals x squared. And it's those points -2, -1, 0, 1, and 2, 4, 1, 0, 1, 4. So we get those right there.
Okay, I'm gonna be writing that down. So
Sounds good.
got it.
Okay, so the first transformation is, and this is new, this makes this problem different, is left 3 units. That first one is left 3 units. That actually affects the x value. So left 3 means every x value, you're going to subtract 3 from each left value, from each x value. So instead of -2, you're going to subtract 3. Okay, and sometimes that's confusing. So let's actually start down here at the bottom. What is 2 minus 3?
2 minus 3?
Yes,
-1.
-1. The next one is 1 minus 3. That's -2.
Okay.
And then it's 0 minus 3, -3. -1 minus 3 is -4 and -5. So again, this is like one of those things that's just, it's going to look different than the previous problems, but because it's going left now. So we're going to graph this, definitely get this table down.
Okay.
I'm going to go grab that first transformation graph. I hear some sighing. Are you okay? Do we
No,
need to
no, no,
get
it
your,
was my paper.
get your dad in there? No, we're all good.
Yeah, yeah, yeah. It was my paper.
Okay.
Yeah, my paper is just making sounds.
Sounds a lot like how I sigh when I'm, you know,
I'm not sighing. I'm not sighing.
okay. It's okay if you are. I do it. I do it too.
Mhm.
All right. I'm going to start plotting these data points.
Yeah, yeah, I'm just almost done. I'm just almost done.
And what you're going to notice when you graph this is that it actually looks really similar.
Okay, got it down. I got it. I got it down, Matthew.
You have this graph down?
Mhm.
Great. So the next transformation, can you read that to me? That next transformation up there from above?
Mhm. Right up there, a -5, 4, -4, 1, -3, 0,
No, no,
-2, 1.
transformation here. What the vertical stretch by 2?
Vertical stretch by 2. It's for 5. Is a vertical stretch by 2 is now going to be for the -5, 4, -4, 1.
It only affects the y values. So
Yeah,
the,
yeah.
the y values are going to multiply by 2, not the x
Okay.
values.
All right.
So the x values stay the same, but the y values are going to double now.
All right. Okay.
We're going to graph that. So I'm going to snip in the next transformation. This is the second of 3. Oops, there it is. All right, so the transformation here, it's gonna pull everything up, but we're still gonna graph the data points. So it's -5, 8.
Okay. All right. I got that. I already got that. I'm just going to be just putting down the transformation.
Excellent. Be done before you know it.
Yeah.
And just let me know when you're ready to move on to the last one, last transformation.
Yeah. All right. Got that. I got that down.
Great. What is the third and final transformation?
The third and final transformation.
Yeah, go back to your list here. What is the last one here? What does it say?
Down 4 units.
Down 4 units. That affects the y again. So down 4 means all the y values you subtract 4. That's what it means to go down by 4 units. The x values stay the same, but the y values go down by 4.
Okay.
So that's 4, -2, -4, -2.
Okay. All
I'm
right.
sorry, and 4. Okay, and then we'll grab a final graph here of that.
Okay, all right. Okay,
All right, so that does it for this problem, except we do have to do the vertex, domain, and range. So the vertex is this point down here. Actually, sorry, let me grab this this bottom part of the page to snip in.
okay. And after this, there's only one more, it's 14.
Yeah, so we're moving right through it. So that vertex is that bottom point there. It's right in the middle of our table.
Yeah, it's gonna be negative, wait, 3, 4, negative 3, 4, negative 3, negative 4.
That's right.
Okay, and all real numbers.
The domain is always all real numbers as far as we're concerned. And the range is y greater than or equal to, and it's the y value from the
Y,
vertex.
y equal then, wait, what is that thing under the
This means
thing right there?
greater than
Greater than,
or
greater
equal
than
to,
negative 4.
which means it could be exactly that value.
Okay, all right. Okay,
All right, let's go look at question 14.
that's our final problem.
That is the final problem. All right, so here we go. All right, so sketch a graph, same thing as before. We got to figure out what is the parent function. What is the parent function? What do you say, Sourish? What is the parent function here?
All right,
What do you think here? What is the parent function?
x2.
X squared, perfect. This time there are only two transformations. The first one is this -3 inside here. So remember from the last problem, when it was +3, it went left. If it's -3, it's going to go right 3 units. And then this 2 is the next transformation. A number on the outside affects the stretching. So that's a vertical stretch by 2.
Okay, all right.
Okay,
There
so
we
what
go.
is, so the first graph we're gonna make is the one we've been making for all the last problems. It's the parent function y equals x squared. So we're gonna do that quickly, and then we're gonna do each of the two transformations here. So parent graph
Two
is,
transformations, it's right 3 units and vertical stretch by 2.
right, we're gonna do them one at a time here. So we got y equals x squared. Make your table, x and y. So that's -2, -1, 0, 1, and 2, 4, 1, 0, 1, 4. Let me know when you get that down.
Okay, I already got that down. Let me just make that a graph of it. Let me just make a graph.
Okay.
All right, I got that down. So the transformation we're doing first is right 3 units. Can we do it first?
Yeah, right, 3 units, and that affects the x value. So
Okay.
you add 3 to each of these x values right here. And if it's easier, start at the bottom, like what is 2 plus 3? Because you have to do them all, but you might see the pattern. 1 plus 3 is 4, 0 plus 3 is 3, -1 plus 3 is 2, -2 plus 3 is 1. And you start seeing the pattern. Oh yeah, they're in order.
Yeah.
The y value does not change. And then we want to graph this. So we're doing this first transformation, right 3.
Okay, got it down. So now vertical stretch by 2.
Yeah, that's the last one. So we're going to multiply all the y values by 2. So every y value you see in this list, we're going to multiply by 2. The x's are going to stay the same though.
Okay.
So 4 times 2 is 8, 1 times 2 is 1, 0 times 2 is 0, 1 times 2 is 2, and then 4 times 2 is 8. And then we'll do that last graph here.
This is gonna be so hard, right?
I think this will be just like your test. If you understand these questions, I
Yeah,
think
I
you're
think
gonna
it's
be great
gonna
on.
be in the test. I think it's gonna be in the test.
So let me know when you get this down and we'll do the vertex and the domain and range.
Yeah. All right, got it. I got it
Okay.
down. So the vertex is the vertex. Okay.
Vertex is always that middle point on our table.
The
3,
middle
0.
point.
And you can actually see it right there too.
Yeah.
It's
Yeah. Okay. So it's
so-
3, 0.
Yep.
The domain, all real numbers.
Yep. Now the range is y greater than or equal to, and it's whatever the y value is of the vertex.
It's 8.
The y value of the vertex. See how the y value of the vertex is 0.
Oh.
In all of the problems we've done, this number is matched.
Oh, okay, maybe. Okay. Thanks.
Yeah, that's it's great you see that.
Okay, thanks.
Yeah, so in the time we have left, I posted something to social media today. It's kind of a fun little question. I'd like to snip it in here and see if you've seen anything like this before, and we can maybe even work through it in the few minutes we have left if you want here. So have you ever seen any questions like this?
Yeah. I saw that before. I saw that before, like several years back.
Right. So this is actually a system of equations. It's something you might see later in this class, but it's in pictures.
Maybe I think it's a little similar to the to algebra to the algebraic equations.
Yes. So can you tell me what the one strawberry is equal to in this first equation?
Well, it's gonna be easy. It's gonna be easy. It's 6 plus 6. Oh wait, no, not that. 8 plus 8 plus 8.
8 plus 8 plus 8. Okay.
Yeah, I think I've seen this before. Yeah, I've seen this before.
So this next one is a little bit harder. You have to figure out what this is. This grapes or blueberries. It's not really clear. Doesn't really matter, but any idea what that's? 8 times some number, but then you subtract 8, you get 80.
Okay, and that's gonna be easy. Okay. It's 11.
It is 11. Yeah, excellent.
Yeah,
So that's
I know that.
11, right? So that's 11. This last one's the hardest one though of them all, because you don't know this value here, but you have to multiply by 11 and then subtract the same value to get 120.
Okay. All right. It's 11 times 11 minus 1.
But these have to be the same. So you're close though. Like what you said is it's 11 times 11 minus 11.
No, not 11, 1.
But whatever this first thing is, this has to be the same. So it's bigger than 11. Because 11 times 11 is 121 minus 11 is 110. So it's got to be bigger than 11.
I was saying it's the last one is 1. So 11 times 11 is 121 minus 1.
That's true,
1.
but the symbol here is the same as the symbol here. So let me give it to you because we're running out of time. It's 12 times 11 minus 12.
That looks different.
These are the same symbols. I promise you.
Okay, I trust you. I trust you.
Yeah. Okay, so now that you have all three, you just got to get them in the right order here. 11 plus 12 times 8. Do you add or multiply first?
So 11 are the purple ones, and the strawberries are the 8,
Yep.
and the cherries are the 12.
Yes. And
Okay.
so the question is, do you add or multiply first? What does order of operations tell you?
You have to add first.
Multiply first.
Multiply.
Multiply.
8 times 12.
So that's 96 plus 11 is
107.
107. Great. All right. Why don't you grab your dad? We'll let him know we're all done. And
Thank you, Matthew,
see you,
for
yep,
helping
see you
me
next.
so I
You're
can
welcome. See you next time.
Yep. Dad.
Yeah. Hello, hi.
Hey, Dr. Kithari. So we got through the worksheet, that's all done. I think he understands. He's got a test tomorrow. This is a question I threw up on social media today. I made this up, and your son seemed to really like this style of question. It's systems, but they're actually kind of scrambled and stuff. He seemed to really like these. I don't know if the visual nature of this impacted him. But he seemed to really enjoy working through this. Maybe it's just totally different, so he got excited, but
Okay, good.
I've got more stuff like this I can work with him on if we ever have time for that. So
Okay, great. Yeah, nice. So I think as long as he's understanding and he's moving forward, so far you think his maths skills are
he
okay.
seems to understand what we're doing. I'm sure the testing environment is stressful and harder for him. But I would assume you should see a great increase over the course of the semester.
Okay.
It's really helpful that we do, and I've said this many times, but like doing the problems he's going to see in class,
Yes.
there's going to be something that translates from our sessions to the tests, like familiarity with them.
Right. Yeah. So he's doing at grade level.
I think he's understanding. I don't know what you're seeing in terms
I
of his
think
grade.
I'm a little bit understand.
Okay. Okay. Good.
I would like to see him do more of the work on his own,
Yeah.
but we may not be able to do that. We'd have to have more time. This took a lot of time to go through these problems. They're very
Okay.
long for him.
Okay.
But if you
at 9th grade level, right?
yeah, he's on track.
Okay.
I don't see any issue. Maybe a few more weeks I can give you a better sense, of
Okay.
what I'm seeing. But I think the lessons are going great. I appreciate you guys scheduling 2 times a week. I think it's really helping him because he's, getting that familiarity with the classwork, seeing it a second or third time.
Yeah. Yeah. I think next time, if he has any classwork, let him send, text you,
Yes, that
or
works
you
great.
text from your phone, the Matthew number,
Yeah,
right?
yeah.
So that you'll be ready also. So next Tuesday, okay? If you have anything by Monday, you have to send him.
Yeah, you can text me, Sourish, anytime. I use that phone just for this business, so it's not an interruption to me if you text me and any pictures that you want. So
Okay.
all right, well, thank you guys. I'll see you next week. Hope you have a great weekend.
Yeah, you too.
Yep.
Yeah.
Thank you, Matthew.
You're welcome. Bye now.
Thanks. Bye.